Hello engineers, another sample problem for mechanics of deformable bodies, module 4 under axial load. So the problem states, the post is made of Douglas fir and has a diameter of 100 millimeters. If it is subjected to the load of 20 kilonewtons and the soil provides a frictional resistance that is distributed along its length, and varies linearly from W equals 4 kilonewton per meter at Y equals 0 to W equals 12 kilonewton per meter at Y equals 2 meters. Determine the force F at its bottom needed for equilibrium. Also, what is the displacement of the top of the post A with respect to its bottom B? Neglect the weight of the post. Okay, so we can start by determining the resultant of the distributed load. So as stated in the problem, at this point, the value of W is 4 kilonewton per meter. And at this point, that's 12 kilonewton per meter. So if you want to determine yung kanyang resultant, we can just get the average of these values. So we have 1/2 times 4 plus 12. And then we can multiply it by the distance 2 meters. So here, ang kanyang unit is in kilonewton per meter. And then evaluating it, we'll have 16 kilonewton as the resultant of the distributed loading along the 2-meter length of the post. Then our next step is to determine the value of F. So by taking a summation of forces, vertical equals 0, positive upward, we have negative 20 since downward siya. And then we have positive 16 since upward yung kanyang resultant. And then we have positive F as assumed in the figure. And that will be equal to 0. So from here, we get F equal to 4 kilonewtons. So the next thing that we have to determine is the displacement of the top of the post A with respect to its bottom B. So let's call that delta A with respect to B, which is equal also to the integral of end of x dx divided by A of x and E of x, assuming that the normal force at each section is varying, the area is varying, and the modulus of elasticity is varying. However, in this problem, it's already stated that the diameter is 100 millimeters. So hindi naman siya tapering or varying. The area is constant. Therefore, A of x is equal to A, which is also equal to the area of the 100 mm diameter post. So we have pi over 4 times 100 squared and then square millimeter. For the modulus of elasticity E of x, Hindi rin stated sa problem that the modulus of elasticity is varying. So we'll have E of X equal to E. And since hindi stated sa problem ang value ng modulus of elasticity, we will base our value on the reference book. And that is 13.1 gigapascal. And then next, for N of X, we cannot say that this normal force is constant because of the varying distributed load. So from here, let's rewrite. We have 20 kilonewtons applied to the post, and this is our post. And its length is 2 meters. And then Y starts from the top. We have point A, point B here, and this one is F. And then we have the frictional resistance W. We have here W equals 4 kilonewton per meter. And here W equals 12 kilonewton per meter. So for us to determine the value of N of X, however, in this scenario, N of X becomes N of Y. So for us to determine the value of N of Y, we have to take a section here, and then this becomes, again, 20 kilonewtons. This is the post and the section here. So we have this normal force as a function of Y, and then yung ating frictional resistance. And this frictional resistance, kailangan natin siyang i-determine in terms of Y value also. So again, here, W is 4 kilonewtons per meter. So our next step is to determine the value of W in terms or as a function of Y. So how can we determine? Better if we can create a tabulation. So let's say Y value and then the value of W as a function of Y. Starting from 0, the 0 value of Y is here. Ito yung Y equals 0. Or here also, Y equals 0. So at Y equals 0, ang value ng ating W is 4 kilonewton per meter. And then at Y equals 2 meters, ang value ng ating W is 12 kilonewton per meter. So from here, this tabulation, we can use the calculator. So kung meron kayong calculator, you can use the function mode 3, 2. So this is linear, and this is written as Y equals A plus BX. So sa calculator, pwede nating i-type these values. So at the X column, write 0 and 2. And then in the Y column of the calculator, write 4 and 12. After natin ma-input yung values, we can just push yung ating AC button and then shift, then 1, and then 5. So here, meron tayong options to determine the value of A and B. So for A, we have shift 1, 5, 1. and then we get the value of A. So for V, we have shift 1, 5, 2. Then we can get the value of B. So using the calculator, we'll arrive with Y equals 4 plus 4x. And this equation we can now use to determine the value of the normal force. So here we can convert in terms of the original problem. So this becomes W of Y is equal to 4 plus 4y. And this value now can be used here. After that, we can now get the resultant. So the resultant is, again, the average. Average of what? Average of the load intensity at y equals 0, which is 4, and the load intensity at y equals y, or at the section located. So 4 plus w of y multiplied by the length, which is equal to y also. And then substituting the value of w of y, we now have 1 half 4 plus 4 plus 4y times y. And then simplifying, we have 1 half 8 plus 4y times y. Distribute natin yung 1 half, we get 4 plus 2y times y, and then we'll end up with 4y plus 2y squared. Ito na yung ating magiging resultant in terms of the value of y. So to check, as computed earlier, we have r equals 16 as the resultant. So if y is equal to 2 meters, r will be 4 times y plus 2 times y squared. And then we'll end up with 16 also. So this equation now represents the resultant of the frictional resistance in terms of y value, or the location of this section. So now, going back here, we can now get or take a summation of forces. So we have minus 20 plus r, and then minus the normal force in terms of y equals 0. Since we now have the value of r, substituting the value, we have minus 20 plus 4y plus 2y squared minus n of y is equal to 0. So simplifying, we have n of y is equal to negative 20 plus 4y plus 2y squared. So going back sa ating formula ng deformation here, so we now have the value of n of y, and then we have a, we have e. We can now compute for the value of delta a with respect to b. So delta a with respect to b is equal to the integral of 0. The total length is 2 meters. And then n of y is negative 20 plus 4y plus 2y squared, and then dy divided by the area, which is pi over 4 times 100 squared millimeter squared, and then the value of modulus of elasticity, which is 13.1. Multiply natin ng 1,000 para we can use megapascal. Take note also that the unit of this expression is in kilonewtons. So what we can do is we can multiply it by 1,000 para the unit na becomes Newton. So evaluating this expression will arrive with delta of A with respect to B as negative 0.259 millimeters. So what does the negative sign means? So going back here, negative sign means that point A, extend lang natin, point A here, and then point B. Since the deformation is negative as computed, it means na si point A with respect to B goes downward. Bakit downward? Since this is the original length and the deformation is negative, that means na nagkaroon tayo ng contraction. So for it to contract, the movement should be from point A to point B. So that's it. Thank you for watching.